Hello, my dear student. I hope all of you are good at home and doing your homework as well and watching the videos regularly. So, previous lecture, we already discussed how we can find the inverse of a matrix by using adjoint of a matrix. Adjoint or কোনো এটা মেট্ৰিক্সৰ এডজইন উলিয়াই তাৰপিছত আমি কেনেকৈ ইনভাৰ্স উলিয়াব পাৰোঁ we already discuss. In today's lecture we'll discuss solution of system of linear equation using inverse of matrix. System of linear equation বোৰ using inverse of matrix আমি কেনেকৈ solve কৰিব পাৰোঁ. Now consider the system of equations are a1x plus u1y plus u1 z equal to d1, a2x plus b2y plus c2z equal to d2, 3x plus b3y plus c3z equal to d3. These three are the system of linear equation. Now let's check how we can write in the form of matrix. This system of equation can be written as ax equal to b, where a equal to a1, a2, a3, b1, b2, b3, c1, c2, c3, x equal to x, y, z, and b equal to d1, d2, d3. Therefore, now in place of a we will put this one, b3, b1, b2, b3, c1, c2, c3, place of x, y, z, d1, d2, d3. After the multiplication, it is of order 3 by 3 and it is of order 3 by 1. After the multiplication, we will get a matrix of order 3 by 1 and which is equal to a duta condition for equality matrix. Already discussed in chapter number 3. Equality condition to satisfy koribo, then a1x plus b1y plus c1z. যেটো system of linear equation asile etu form korim. So system of linear equation can be written by using this matrix. Now case 1. Now what we have to find to solve this system of linear equation? We have to find the value of unknown. That means here unknown is x, y and z. So in this system of linear equation we have to find the value of x, y and z. Now check how we can do this one. If matrix A is non-singular, what is the meaning of non-singular? That means determinant of A not equal to 0. Non-singular matrix. Then its inverse exists. It already discussed in previous lecture when we discussed the inverse of matrix. Then its inverse exists. Here it is the equation by multiplying both sides with A inverse Ax A inverse B. Multiplying both sides by A inverse. What we are getting? A inverse into A, that is I into X. A inverse B. Identity matrix হল যিকোনো matrix multiply কৰিলে আমি হেতু matrix পাওঁ, that is X equal to A inverse B. It is very important. By using inverse of a matrix, we can find the value of unknown from a system of linear equation. There is a case number 2. That means there is another condition that can be happen. If matrix A is a singular matrix, then determinant A equal to 0. It is the condition for singular matrix. If first condition here A, determinant A equal to 0, and if adjoint A into B not equal to 0, then solution does not exist and the system of equations are called inconsistent. Very important. Etu condition to satisfy koribo lagib. Ami only determinant A equal to 0 pale ami solve solution to complete hua boli bhabibo nalagibo. Don't think that your solution is completed whenever you get determinant of A equal to 0. Okay, then after getting determinant of A equal to 0, you have to check adjoint of A into B. After finding adjoint of A into B, check it is 0 matrix or not. 0 means here 0 matrix. Then solution, if it is not equal to 0 matrix, then solution does not exist and the system of equation are called inconsistent. Okay, and what is the condition B in case 2? If adjoint of A into B equal to 0, that is 0 matrix, then system may either consistent or inconsistent according as system have either infinitely many solution. System has either infinitely many solution or no solution. What was the condition for infinitely many solution and no solution? Infinitely many solution and no solution. In a system of equation, how we can define these two terms, infinitely many solution or no solution? It would be class 9 train out by sage. What is the condition? A1 by A2 that is equal to B1 by B2 that is equal to C1 by C2. If all of these are equal, which is not equal to D1 by D2, then these three have infinitely many solution. or null solution. Here's a question. Check whether consistent or inconsistent, consistent or not. Following system of linear equation: x plus y plus z equal to 1, 2x plus 3y plus 2z equal to 2, ax plus ay plus 2z equal to 4. How we'll check? Now we'll check whether the system of linear equation are consistent or inconsistent. Those system of linear equations can be written where ax equal to b, where a equal to 1 to a, where a equal to 1 to a, 1 3a, 1 to 2a, x equal to x y z, b equal to 1 to 4. That's it. Now what we have to check, whether inverse exists or not. To check the inverse exists or not, we have to find the value of determinant a. How we'll find this determinant a? 1 into 6a minus 2a minus 1 into 4a minus 2a plus 1 into 2a minus 3a. Simplification: 1 into 6a minus, that is 4a minus 2a minus a, that's number a. Now there is a condition: if a not equal to 0, then determinant a not equal to 0. If we check the question properly here, if we put a equal to 0 0 0, then this equation, we cannot write this equation. It is not possible. It equation to possible no. That's why a should be not equal to 0. Therefore determinant a not equal to 0. So a inverse exists. That means what? That is the system of equations is consistent. Now let's draw a numerical to solve a system of linear equation by using inverse of a matrix. Let's solve this question. Solve the system of equation 2x plus 5y equal to 1 and 3x plus 2y equal to 7. Check how we can solve this one. The system of equations can be written as ax equal to b, where here a will be of order 2 by 2, and because here only 2 equations are available, not 3 equations. So first value of x2 by 5 3 2. We have to put the coefficient of x and y here, and in matrix x it will be x and y, and b will be constant term, that is 1 and 7. Now what we have to do is first check whether its inverse exists or not. To check whether its inverse exists or not, we have to find the value of determinant A. That is 2, 5, 3 and 2. What is the value of this determinant? 4 minus 15 minus 11, which is equal to not 0. Therefore, A inverse exists. So what we need to do is find A inverse. How we can find A inverse? Determinant of A into adjoint of A minus 11. Adjoint of A, 2 by 2 matrix. So adjoint we can easily find these two interchanging and these two. That is our inverse. You can keep it like this way also. You can multiply this 1 by minus 11 also. So what is the value of x? A inverse B. A inverse means 1 by minus 11, 2 minus 5, minus 3, 2. And what was our V? 1, 7. After this simplification, you multiply these two, you will get a matrix. It is 2 by 2, it is 2 by 1. That is 2 by 1 matrix. You will get, what was that? 3 minus 1. तुम्हारे का simplification कोई लोगा here x and y. By comparing these two, you can find easily the value of x equal to 3 and y equal to minus 1. That is the solution of our system of equation. Okay, my dear student, I have solved few more questions. Solve the following equation or system of equation. There is the equation x minus y plus 2z equal to 7, 3x plus 4y minus 5z equal to minus 5, 2x minus y plus 3z equal to 12. The system of equation can be written as ax equal to b. It already we discussed a Mijikuno linear equation, a system of linear equation can written as this way, where a equal to the coefficient of all the variable. X variable 1, first equation, then y variable minus 1, 0, 2, 3, 4, minus 5, 2, it is 3, 2 minus 1, 3, and x equal to x, y, z, and here b equal to 7, minus 5 and 12, that is the constant term. Then to solve this equation, first we have to check whether A inverse exists or not. To check whether A inverse exists or not, what we have to do is we have to find the determinant of A. A matrix to is 1, 3, 2. Then determinant of A will be 1, 3, 2, minus 1, 4, minus 1, 2, minus 5 and 3. After calculation, we will get the determinant of A equal to 4, which is not equal to 0. That is non-singular. A equal to not 0, that means what? It is a non-singular. So A inverse exists. To find A inverse, what we have to find is, we have to find adjoint of A. How we can find adjoint of A? By taking the cofactor of all the elements. First element of cofactor is 7, second row minus 19, minus 11. Then again, cofactor, with the help of cofactor, will form a matrix and take the transpose of that matrix, we'll get adjoint of A. Okay, we already calculated 7, 1 minus 3. You can check or you can verify by using calculate. By using the calculation yourself. 7 minus 19 minus 11, 1 minus 1 minus 1 minus 3, 11, 7. So what is the formula? We find x by using this formula, x equal to A inverse B. We already showed in first. Therefore, here, what is A inverse? Already discussed in previous lecture. A inverse equal to 1 by determinant of A into adjoint A. As x equal to 1 by determinant of A adjoint A into B. we put the corresponding value. Determinant of A equal to 4, that's its adjoint 7 minus 19 minus 11 1 minus 1 1 minus 3 11 7, and it's 7 minus 5 12, each of order 3 by 3, and it is of order 3 by 1. After the multiplication, the order of the product will be 3 by 1. This 3 by 1. So after multiplication we get 8 4 and 12, and here is a constant term 1 by 4. You have to multiply with it each and every element. After multiplication you will get 2 1 3. Now what was our X, capital X matrix? It is X Y Z, and this is 2 1 3. Comparing this two, we'll equate the corresponding element. First element X equal to 2, Y equal to 1, Z equal to 3. That is the solution, required solution. Now check another question. Read the question properly. The cost of 4 kg onion, 3 kg wheat and 2 kg rice is rupees 60. First condition. Question at first condition at ki diya ase bhalke read kora. The cost of 4 kg onion, 3 kg wheat and 2 kg rice is rupees 16. Make a linear equation of 3 variables. You already learned in class 10. So you can easily form an equation from the first condition. Now check the second condition. What is it? The cost of 2 kg onion, 4 kg wheat and 6 kg rice is rupees 90. It is the second condition. From the second condition itself, you also can find a linear equation of 3 variables. The cost of 6 kg onion, 2 kg wheat and 3 kg rice is rupees 70. So what is the question? Now find the cost of each of item per kg in per kg. It is the important one, by matrix method. That is by using the inverse of a matrix. Now let's see how we can solve this one. Let us first consider the price per kg of onion, wheat and rice be respectively rupees X, rupees Y and rupees Z. Then from the first condition, here 4 kg onion, so 4 into X, per kg MRP is X, 3 kg wheat, so 3 into Y, and 2 kg rice, 2 into Z, that is equal to rupees 60. It is our first condition. Similarly, second condition will be 2x plus 4y plus 6z equal to 90. And similarly, third condition 6x plus 2y plus 3z. That means 6 kg of onion, 2 kg of wheat and 3 kg of rice equal to 70. The system of equation can be written as ax equal to b, where a equal to, it is the coefficient of the variable. Coefficient of variable. From the first equation 4 3 2 2 4, it is 4 6 6 2 3, and x equal to x y z, and your b will be the constant term 60 90 and 70. So b will be 60 90 70. Then 4 3 2, what we have to check? To check whether A inverse exists or not. To check whether A inverse exists or not, we have to find determinant of A. So determinant of A equal to 50, which is not equal to 0. That is, it is a non-singular matrix. So A inverse exists. Now to find A inverse, what we have to find? We have to find adjoint of A. To find adjoint of A, you have to take the cofactor of each and every element and make the transpose of matrix formed by their cofactor. So my cofactor to beleke ulai loisu. Yes, 0 minus 5 10 30 0 minus 20 10 and 10. It is the cofactor of each and every element. I have to take the transpose of this cofactor. So after taking transpose, 0 30 minus 25 0 10 10 minus 20 10. Take x equal to A inverse into B. We already know this one. A inverse equal to 1 by determinant of A into adjoint A into B. It is B. So 1 by determinant A 1 by 50, adjoint of A 0, 30 minus 10. It is not minus 10, it is minus 20, minus 5, 0, 10, 10 minus 20 and 10, 60, 90, 70. So after multiplication of these two matrix, we'll get 250, 400 and 400. And 1 by 50 will be multiplied with this 588. So from this, equating these two matrix, we'll get x equal to 5, y equal to 8 and z equal to 8. So therefore the price of onion per kg is rupees 50. Price of wheat per kg is rupees 8, and the price of rice per kg is rupees 8. That is the required solution. Now there's a few homework for you. Let's check the homework properly. Only two homeworks. Solve the following system of linear equation by using matrix method. So the equations are this two. 5x plus 2y equal to 3. So easily calculate koribo pariba. So submit the homework before the next class. Au kuneu karopa copy no koriba. Dekha paiso kisumane copy kori submit kori ase. It's not good. Okay, thank you.